Greetings and welcome. Last night we were doing our homework on page like 596-ish, and we were talking about products and quotients of complex numbers in polar form. So here I've got two complex numbers in their polar forms respectively, and what we found out was when we multiplied two of them in this form, that my new modulus, getting a little lag there, there we go, is equal to R1 times R2, there we go, and my new amplitude is equal to theta 1 plus theta 2. So I can actually find those and do wonderful things with them. Isn't it great? So R is going to equal 5 times 2, or 10. And theta is going to equal pi plus 3 pi over 4. And in order to simplify this theta, I'm going to have to find a common denominator, which is 4 multiplied by 4 over 4. And 4 ply, that's like really durable toilet paper. 4 pi plus 3 pi is 7 pi over 4. There we go. I don't know. I'm sorry, internet friends. By the way, just so you know, I'm on cold medication right now. Not as in like, well, I guess it is like not used recreationally, let's say. Used medicationally. So, but my brain's all messed up. My apologies. So there we go. Saved myself on that one there, exactly. So now I can write the new form. So that's going to be 10 times the cosine, or actually, tell you what, let's use the shorthand. Cosine I sine of 7 pi over 4. Now, if I want to get this back into rectangular form, were they interested in that? I think they were. Yeah, cool, sweet. So if I want this in rectangular form, I'm actually now going to have to just kind of simplify all this. So 7 pi over 4, first of all, is almost a full 2 pi. That's an ugly... Right there, I think, is 7 pi over 4, if I'm not mistaken. So what is the reference angle? Or pi over 4 is the value of my reference angle. And cosine is positive, whilst sine is negativo in that quadrant. So if I want to evaluate this is going to be the same as 10 times the cosine of pi over 4 minus, because sine is negative, or I guess I'll write it this way, plus I times the negative sine of pi over 4, sorry. There we are. And now what I can do is do 10 times cosine pi over 4, root 2 over 2 to do, and minus root 2 over 2 of, over 2 of I, and then distribute, so that's 5 roots of 2 minus 5 roots of 2. There's my rectangular form of A plus B, I, right there coming at you. So, good stuff, good stuff. But yeah, the idea of this was we had a nice little short way of multiplying those rather than doing crazy stuff. And it's actually, I think it's kind of cool how these simplified oh so nice. So, last example, here's question 25. It says, use polar form to find each product or quotient, express the result in rectangulario form. So, first of all, these are both in rectangular form. So in order to go back, I'm going to have to find my r and theta. R is equal to the square root of a squared plus b squared. Tan theta is equal to b over a. There we go. So for my first complex number, I'm going to have r is equal to the square root of 2 squared. Man, that was like so great. That was almost the square root of 2 squared. Man, I love it. Plus the negative square root of 2 all squared. What? 2i? 2. Well, the I, I'm just using the b though, not the, you know. Square root of 2 squared is 2. Negative square root of 2 all squared is 2. This is the square root of 4, which is 2. I don't know if you know that. Bam. Then I've got tan theta is equal to negative root 2 over root 2. So tan theta is equal to a negative 1. Tan versus both sides. And I would get theta is equal to, what's that going to be? Tan inverse of negative 1. Doesn't that occur at 45 degrees as a reference angle, if I'm not mistaken? Yeah, according to the finger trick. Or pi over 4 maybe is how I should write it. And which quadrant am I in? Let's see, this would have been over down quadrant 4. So then theta would be 360 minus alpha because it's quadrant 4. You guys agree? You know what I'm saying? For this point, because, yeah, you know what's up. Right, I went over the square root of 2, down the square root of 2, and there we go. So that's going to be, I just said 360, guys. How terrible when I'm using radians. But you know what I mean. I mean 2 pi. So theta is then equal to 2 pi minus pi over 4 is 8 pi over 4 minus pi over 4 is 7 pi over 4. Not unlike the problem I just did moments ago. So all this work I just did merely gave me the modulus and amplitude for the first point. I now have to do the same thing for that one. So let's do it. Do it to it. Maybe I'll even call this R1 and theta 1. How about? So R2 is going to equal the square root of the negative 3 square roots of 2 all squared plus another negative 3 square roots of 2 all squared. Bah! Trying to like bring the energy to this even though I'm like, bleh. Square root of negative 3 all squared is 9 times root 2 squared is 2. 9 times 2 is 18. Same thing over here. Oh, what? Square root of 36. How wonderful. 6. R2 is equal to 6. There we are. Let's do the other version of calculating this. Theta is equal to what? The arctan of B over A. I believe what? Plus pi. You guys remember that version? You could have still used this one if you wanted, but since my value of A is negative, I can use this formula here. And if the value of A was positive, then it would have scratched off the plus pi. Might as well let you see what that looks like as well, since it's oh so similar. Arctan, I could even refer to that as tan inverse of negative 3 roots of 2 over negative 3 roots of 2 plus pi. By the way, tan inverse of that is the same as tan inverse of positive 1, which is pi over 4 plus pi. So my theta's 2. I guess I'll do some fraction work for you because I like you guys there. So we'll call this pi plus 5 pi, 4 pi, 5 pi over 4. Like so. So now I've figured out R1, theta 1, R2, theta 2. So what does this represent? That means, what is that? 2 and 7 pi over 4. So that's 2 times cosine I sine of 7 pi over 4 multiplied by 6. Lagging. Times the cosine I sine of 5 pi over 4. Right, and now I'm doing a problem not unlike the one I just did over here, where I'm multiplying two things that are in polar form, that are complex numbers, so I can use my awesome new little tricks, such as the fact that R is going to equal R1 times R2, and theta is going to equal theta 1 plus theta 2. So R is equal to 2 times 6, or 12. Theta is equal to 7 pi over 4 plus 5 pi over 4. So my theta's equal to 12 pi over 4, or 3 pi. Which, if I want to try to like get rid of, I guess, the coterminal angle sort of thing, 3 pi is the same as 2 pi, or sorry, 1 pi, by the way, or 180 degrees. Right? Yeah. So here's 3 pi. That's the same if you wanted to think about it just as like plain old pi right there. So eliminate the coterminality there. And now that I've got 12 and pi, I can write their product as 12 times CIS pi. And did they want this in rectangulario? I think they did, didn't they? So that would be 12 times cosine pi plus I times sine pi. Cosine pi, I got this wrong yesterday, is 0. No, -1. I just got it wrong again. That's how good I am. Plus I times sine of pi. The y coordinate when I'm at this location is 0 in that case. So it turns out the answer to this is -12. Which, craziness, huh? Craziness. So, to overview what I did, I took 2 rectangular form complex numbers that were being multiplied. I converted them into polar form. I used my awesome polar form magic to find the new product, and then I converted that product back into rectangles. Bam. Rhombangles. Bye-bye, friends.